class is going to cover fractions and the basic operations on those fractions, or addition, subtraction, multiplication, and division, and some exponents. So on the second page, or the back of the first page, there's some definitions of fractions. Some of the terminology we'll be using in the workshop. With the numerator is the top number of the fraction, the denominator is the bottom. A whole number is anything, for instance, number 7, we can write 7 over 1, correct? So any whole number can be written over 1. Proper fractions are fractions where the top number is smaller than the bottom. That means an improper fraction is where the number on top is bigger than the number on the bottom. So we're going to be using some of that terminology in our operations as we go along. So let's go to the top of the first page and talk about reducing fractions. We have 36 over 4. Now my suggestion is to first check to see if the bottom number goes into the top number evenly. Because all a fraction is a basic division problem. So can 36 be divided by 4? Yes. So if it goes in evenly, the reducing is just a division problem. So 36 divided by 4 is 9. And we're done. Don't need to worry about dividing both the top and the bottom, getting it down lower. If the bottom goes in evenly, that's your number. Let's talk about another one. Everybody good on that one? Now, you have to think of a fraction as a division. 3 does go into 18 evenly, right? But it's never that order of the division. It's always the top number divided by the bottom. So can 18 go into 3 at all? No. So this one we have to reduce. What's a common number that goes into both of them? 3. So we can divide top and bottom by 3. So 3 divided by 3 is 1. And 18 divided by 3 is 6. And that would be our reduced fraction. The most common mistake we see on this type of problem is somebody will write 6 because they think the division goes this way. 3 can go into 18 6 times. But that's incorrect. We have to keep the same proper fraction. Any questions on that one? The next one is 15 over 25. So is there any number that goes both into 15 and 25? 5. So 15 divided by 5 is 3. And 25 divided by 5 is 5. And that would be our answer. Any questions on that one? Over 48. Does 48 go into 72 evenly? No, so we can't do the division part. But we can reduce it. Can anybody think of any numbers that go into 72 and 48? 9. Somebody say 8? Let's try 8. So 72 divided by 8 is? 9. And 48 divided by 8 is? 6. Can that still be reduced further?
Yes.
Yes. If it can still be reduced, we have to go further. Is there a number that goes into both 9 and 6?
3.
So 9 divided by 3 is?
6.
And then 6 divided by 3 is 2. And that's an improper fraction. We'll leave that like that for the time being. The next section we're going to talk about converting between improper and proper fractions, or mixed numbers. All right, everybody good on that one? The next section, 2 and 3/5. So we want to take this mixed number and convert it into an improper fraction. We need to know how to do that to do multiplication and division with mixed numbers, so it's a good skill to have. So how do we go about doing something like that? How do we change that into an improper fraction?
You multiply 2 times 5.
Right?
And then add 3.
Right. Some of the instructors say going around the world, 2 times 5, you multiply, and then add. So 2 times 5 is 10, add the 3, 13, and then you always keep the same denominator. 13 does. Correct. So let's try another one. 5 and 7 ninths. We're going to multiply times the bottom and then add the top. So 5 times 9 is 45. We add the 7, 52. Always keep the same denominator. So this equals 52 over 9. So we need to know how to go from mixed numbers to improper, but we also need to know how to go backwards, changing an improper fraction into a mixed number. Okay? So let's try that. Anyone have any questions on these two? So let's say we have 11/5. We want to change this improper fraction into a mixed number. So it basically turns into a division problem. You're thinking of it as 11 divided by 5. So how many times can 5 go into 11? 2. 2 times 5 is 10. We get a remainder of 1. Well, how do we convert that into a mixed number? Exactly. This number up here is going to be your whole number. This will be your numerator. And your denominator never changes, right? So that's going to be your denominator. So 2 and 1/3. So let's try one with a little bit bigger number. 47 over 8. How many times can 8 go into 47? 5. Everybody agree with that? 5 times 8 is 40. We subtract, we get a remainder of 7. So my next number would be 8. Oh, thank you. 5 and 7 eighths, correct. So everybody good converting between improper and mixed numbers? So we're going to need to know how to do that to get some of our answers and do some of the operations. So let's move into adding. So when we're adding and subtracting fractions, we need a common what? Denominator. Most of the time. There's a couple times where you don't have to. So let's talk about some instances first that if you recognize them, you really don't need a common denominator. We can just do some simple addition. If you ever have a mixed number added to a whole number, there's no need to go through the process of finding a common denominator. You can just add your whole numbers together. 2 plus 5 is 7. And then just carry the fraction. And you're done. So if you ever have a situation where you have a mixed number plus a whole number, you can just go straight over here. You don't have to go through the process of doing the common denominator and all that. Okay? Pretty good on that one? Yeah. I mean, you can get the answer. You get the answer going that route. But if you can recognize that, it saves you some time. Okay? All right, let's talk about another one. We don't really need to find a denominator. If you have a whole number plus a proper fraction, you don't need to find the common denominator on this one either. 3 plus 5/8 you can just combine them together and write 3 and 5/8. A lot of times your instructor will put the 1 over, 3 over 1, find a common denominator, and then you have to convert it back into a mixed number. But if you ever have a whole number plus a proper fraction, you just write it as 3 and 5/8. You're done. You're good to go. Okay. But they're not always that easy, right? Everybody good on that one? And sometimes they're nice enough to give us fractions that have a common denominator. So if you already have the common denominator there, you can just add the tops, the numerators. So 3 plus 9 is 12. Always keep that denominator. And then we need to convert that into a mixed number. So how many times does 5 go into 12? 2, with a remainder of 2, and keep the same denominator. Okay. All right, so the last 3 problems that we've done are instances where you really don't have much work to do as far as a common denominator, but they're not always that easy. So let's look at some ones where you have to find a common denominator. What do we do with this one? If you need to find a common denominator, my suggestion is to write it vertically. It makes it a lot easier to see how you're getting your answer. So we have 3/8 plus 1/12. What would the common denominator between 8 and 12 be? 24. How do we get that? Yeah, 24 is the lowest number that 8 and 12 will go into evenly. My suggestion is look at the biggest number. Can 8 go into 12? What's the next multiple of 12? 24. Can 8 go into 24? Yes. So that's your lowest common denominator. So we need to get both of our denominators to be 24. Well, 8 times what gives me 24? 3. And when I do the denominator, I have to do to the numerator. So what's 3 times 3?
9.
Well, 12 times what gives me 24? So I have to do the same thing to the numerator. So 1 times 2 is 2. Now I have a common denominator and I can add them. So 9 plus 2?
11.
Is it a proper fraction? It's not improper. The number on the top is smaller. Any questions on that?
Wouldn't you want to reduce it, or instead of saying reduce?
You always reduce a fraction, but will this reduce? There's no number that goes into both 11 and 24. So we're good to go on that one. We can also do addition with mixed numbers. We have 3 and 5, 6, plus 4 and 1, 8. There's a couple different ways you can do it. Some instructors show you that you can change them into improper fractions first and then add them, or deal with the mixed numbers. I usually just stick with the mixed numbers because you don't have to worry about having some ridiculously huge numbers in the end. So let's stick with the mixed numbers we have here. Looking at 6 and 8, what would our LCD be? Our lowest common denominator? Should be 24 here, correct? And if you're having trouble coming up with that number, the trick is to look at the biggest number. Can 6 go into 8 evenly? What's the next multiple of 8? Can 6 go into 16 evenly? What's the next multiple? 24. Can 6 go into 24 evenly? Yes, so that would be my LCD. So 6 times what gives me 24? When I do it in the bottom, I have to do it in the top. 5 times 4 is 8 times what gives me 24? 3. 10 times 3 is 3. So we're really done with that part of it, right? We're really done with the original proper fractions. So 3 plus 4 is 20 plus 3. And then keep the same denominator. That's there, right? Any questions on that one? All right. So let's try the next one, because it has a little bit of a twist at the end. So our denominators are different again, so we need to find a common denominator between 3 and 4. 12, correct. What times 3 gives me 12? 4. So we're going to multiply the top also by 4. 2 times 4 is 8, correct? 4 times what gives me 12? 3. So I'm going to multiply that 3 on top by 3 as well, correct? We're really done with that part of the fraction. 7 plus 5 is 12. 8 plus 9 is 17. What's wrong with that, the way it
The top
works?
number is bigger than the bottom number.
Right, you can't have an improper fraction as part of a mixed number. Okay, well, how can we fix that?
Divide 12 into 17.
We'll leave that 12 alone.
Yes.
We'll look at this. Let's change that into a mixed number. How many times can 12 go into 17? Once. With a remainder of? Over 12. Yep. What we're going to do is we're going to take these two and add them together. We're going to remember our shortcut from the first section, the first part of the addition. If I have a whole number plus a mixed number, so well, that's going to be 13 and 5 plus. You good going that way? Okay, so the key there is when you're adding, you can't have an improper inside of a mixed number. You're going to have to convert it and then add the whole number that was already there to it. Okay? So that's addition we're going to show. Let's move to subtraction, which is on the back of this. So just like some easy addition, there is some easy subtraction that we can do as well, if you see it. If I have a mixed number and I'm subtracting a whole number, you can just subtract the whole number. 5 minus 3 is 2, and keep that. So there's a shortcut that we can use. It doesn't work the other way, and we'll see that. If it was a whole number minus a mixed number, like problem the 9 minus 2 and 7/10, further down the page, we can't do that easy subtraction. We'll see why. But if you ever have a mixed number minus a whole number, to subtract the whole numbers, carry that fraction, you're good to go. And just like addition, if they give you the denominators are already the same, you can just already go ahead and subtract. So 9 minus 3 is 6. And we want to change that into a mixed number. How do we do that? 1 and 1/5, correct. 5 goes into 6 one time with a remainder of 1. Keep the same denominator. So if you have those two types of subtractions, you don't have to worry about finding a common denominator. You can just move on from there. But we have it that easy, right? Okay. All right. So any questions on those? Let's move into some tougher ones. Four-fifths minus 2/3. Well, we're looking at our denominators that are not the same. In order to do addition or subtraction, we need a common denominator. So for 5 and 3, my common denominator would be what? 15. 5 times what gives me 15?
30.
So we have to multiply times 3 there, and times 3 on the top. 4 times 3 is? 3 times what gives me 15? So I have to multiply that number on the top as well. So 2 times 5 is 10. We don't run into any problems as long as this number is bigger than this one. We'll see when we run into some problems later on. We'll get to that. But 12 minus 10, we can do that. 12 minus 10 is what?
2.
2. Keep the same denominator. It's proper. We're good to go. Can we reduce that at all?
No.
Nope. There's nothing common between 2 and 15 except 1, so we just leave it like that. Any questions on that one? Seven and 4/9 minus 6 and 1/3. So just like addition, we can do subtraction between mixed numbers as well. The process is still the same. We still need to find a common denominator. So between 9 and 3, what would our common denominator be? 9, right? Because 3 goes into 9. So let's use the 9 that we've already got. So 9 times what gives me 9?
1.
1. So we're not really changing that at all, right? Because 4 times 1
4.
is still 4. 3 times what gives me 9?
3.
So 1 times 3 is
3.
3. So we're really done with this part of the fraction. That number is bigger. We're good to go. We don't have to do any borrowing yet. 7 minus 6?
1.
1. As far as the fraction, 4 minus 3 is 1.
9.
We're good to go. Any questions on that one? Now it gets a little fun. Now we're going to get to the borrowing. So the next one says we have 9 minus 2 and 7/10. What's wrong with this one? Why can't we just subtract 2 from 9 and then bring the 7/10 down? Yeah, there's not anything to subtract that 7/10 away from. Right? We need something there to subtract it away from. What we have to do is borrow. So we'll replace that with an 8. And what would I write here? 10 over 10.
Yeah.
Because what does 10 over 10 really mean? 1. That represents the 1 that I borrowed from the 9. Why didn't I use like 7 over 7 or 6 over 6?
Is 10 your denominator?
Exactly. My denominator is already 10, so why not just make it 10 over 10? Right? Makes sense? Helps us out. So now we can just do that subtraction. 8 minus 2. 10 minus 7. There we go. Not too painful. A little different, but not too bad.
What was the reason to do the borrowing? How come we couldn't have done just since it's a whole number?
Well, we have to subtract that because we're subtracting 2 and 7/10. We have to take 7/10 away from something, but there wasn't anything there. It's like when you're doing subtraction with whole numbers, if you have a 0, up there, you have to borrow from the next number over and change it into a 10. It's the same concept. You have to have something to subtract from. Okay? Any other questions? Any other questions? So this is where it really gets interesting. So what would my common denominator on this one be?
15.
15. Lowest number that 3 and 5 go into is 15. What times 3 gives me?
5.
So I gotta multiply that top by 5 as well.
10.
10, correct. What do I need to multiply that one by? So where do I end up on the top? I'm really done with this part. Now before I subtract, can I take 12 away from 10?
No.
Not in this class. Between events and class. So we have to borrow. So I'm going to borrow from the 14. So how am I going to add that 1 to 10 15ths?
15.
15 over 15. That's my denominator, right? So let's add 15 over 15. The 1 that I borrowed. That means the same thing as 1, 15 over 15. So what does that really become?
25 over 15.
So 13 minus 8 is
5.
5. And now I can subtract. I can subtract 12 from 25. So 25 minus 12 is 13 over 15. Denominator never changes. So that's what my answer would be. Now that's the way to show the step. I'll show you a quick little shortcut. Does everybody have these steps down? So I'll show you a shortcut where you don't have to actually go through the process of adding that 1. All right, so we borrowed, let's see. All right. After you borrow that 1, the shortcut is to just, whatever this denominator is, just add it to the numerator. What's 10 plus 15? What's 10 plus 15?
25.
Right, and that's the same number we came up with when we actually worked out the step, and then 25 minus 12. So that's the shortcut. So if you're ever just working it out, you can actually just add the numerator and denominator together, and that will give you what happens when you add 1 to that fraction. Okay? So that's subtraction in a nutshell. Those are really the only 4 types of possibilities you could run into. So let's move into the other 2 operations, which are multiplying and dividing, which are usually easier because you don't have to have a common denominator. You just multiply across, or you can reduce. There's no common denominator involved. Any questions on that last subtraction problem? With the multiplication? So the first problem we have is 3/4 times 36 over 15. Now there's 2 ways you can tackle the problem. One is you can multiply across and then reduce, which some people like doing that. I like the other way, which is reducing before I multiply, because it makes the numbers smaller and you don't have to worry about reducing at the end. If you take care of your reducing at the beginning, you've actually taken a lot of work out of the problem. So you always look diagonally. 4 and 36, is there something common between those 2? The common number is 4. You will get a 9 here, I agree, because 4 does go into 36 9 times. How many times does 4 go into 4?
1.
Once. So we basically reduced both of those by a power of 4, a factor of 4. Anything common between 3 and 15?
3 and 3.
How many times does 3 go into 3?
One.
How many times does 3 go into 15?
Five.
Well, that looks like a lot easier multiplication problem, right? Because now I can just go 1 times 9 is
Nine.
9. 1 times 5 is,
Five.
we always multiply across. We reduce diagonally, but always multiply across. And if I wanted to convert that into a mixed number,
Two.
not quite 2.
I mean, I'm sorry, one and.
Right, 5 goes into 9 one time,
One and
a remainder of 4.
fifth.
Keep the same denominator. So, much easier than addition and subtraction. Now, if you're comfortable with multiplying it and then reducing it, and that works for you, stick with it. You know, I'm not trying to confuse anybody. But this way takes a lot of work out of the problem. Yes, sir.
What you reduce that 9 to? I do get that 4.
I'm changing this into a mixed number. I'm saying, well, how many times can 5 go into 9?
Oh,
One time.
yeah.
And what's the remainder there?
4.
4, and that's where the 4 comes from.
Okay.
Okay? So we're just converting a mixed, improper into a mixed number. Any other questions on that one? Right, let's tackle the next one. Multiplication, we really want to have a numerator and a denominator. So how can we rewrite 4 to turn it into a fraction?
4 1.
4 over 1, correct. So let's look at my diagonals. Anything really common besides 1 with 1 and 17? No, we'll leave that one alone. What about 4 and 26? 2, we can divide both of those by 2. They're both even. So 4 divided by 2 is 2. 26 divided by 2 is 13. And our number's a little bit smaller. 2 times 17?
34.
34, correct. 1 times 13 on the bottom?
13.
13. That's an improper fraction, so we need to change that into a mixed number. How many times can 13 go into 34?
2.
2 times, right? And then,
8.
what would our remainder be?
8, 13.
Correct. All we're doing there is dividing 13 into 34. Okay? Pretty good on that one. Bless you. When you're multiplying or dividing, you have to deal with just fractions. You can't have mixed numbers. So we're going to have to change any mixed number we have into an improper fraction. And how do we do that again? Right, multiplying around the world, then multiply, and then add. So I've got 4/5 times 2 times 16 is 32 plus 3,
35.
35, and my denominator 16. So let's see if we can do any reducing before we multiply. We got 5 and 35, anything common between those two? 5. 5 times what gives me 5? 1. 5 times what gives me 35? 7. Anything common between 4 and 16? 4.
1.
1. And how many times 4 times 16?
4.
Change the problem into a pretty easy multiplication problem again. 1 times 7 is
7.
7.
4.
1 times 4 is 4. Now all I have to do is change that into a mixed number. 4 that goes into 7,
1.
the remainder of in the denominator of. If you would have multiplied across, you would have some really big numbers, and then you would have to change it into a mixed number and then reduce it. If you can get into the habit of reducing before you multiply, it makes it a lot easier. Any questions on that? So in this last multiplication problem, we have two mixed numbers. So before we can actually multiply this one, what do we have to do? Right, we have to convert them. We have to convert them into improper fractions. So we'll do the round the world. 5 times 8 plus the 3 over 8. 2 times 7 plus the 4 over 7. Anything common between 8 and 18?
Yes.
2. So 2 goes into 8.
4 times.
2 goes into 18 9 times. Anything common between 43 and 7?
No.
Unfortunately, no. Right? So sometimes we're just going to end up with big numbers. But the nice thing about it is, at the end, there's no question whether it's reduced or not, because you already took care of the reducing before you multiply. 43 times 9. Anybody got that? 387, correct. 4 times 7, 28. Then I need to convert it into a mixed number. So we need to figure out how many times 28 goes into 38, or 387. So our answer would be 13.
20, 30.
And I know it's reduced because I took care of the reducing here. You take care of it here, you get big numbers over here, you don't have to worry about reducing. You've already taken care of it. All right, so don't worry about it again. That's the nice thing about doing it this way. So any questions on multiplication? The next step, the next part is division. And when we get to division, you're going to see that division really is the same thing as multiplication. We just have an extra step. Okay? So let's tackle division.
With division, would you do the same thing, reduce before you divide?
Division problems end up becoming multiplication problems, and so you can reduce.
It's 36.
36? Thank you. 36. All right, so when we do division, we have to keep in mind this kind of phrase. Same, change, flip. We can't really divide fractions. We have to change it into a multiplication problem and then work it through multiplication. What the same, change, flip means is we're going to keep the first fraction the same. We're going to change division into multiplication, and then you flip the second fraction. It's always the second fraction you flip. When you flip a fraction, that's called its reciprocal. So if you hear that terminology, the reciprocal is just the fraction flipped over. So we've already done this process. It's a multiplication problem, we can reduce. So 4 and 36, what's common there? 1 and 9. With the 3 and the 15?
1 and 5.
1 and 5. Got an easy multiplication problem there now. 1 times 9 is
9,
1 times 5 is 5. 5 goes into 9
One,
one time, with a remainder of,
four.
and keep the same denominator. So notice that division ends up just being a multiplication problem, so you can work them out exactly the same way. Okay. So let's move on to another one. Any questions on that? All right, we just added one step. That same change flip. That's the only thing, that's the only difference. So let's try that.
I got a question.
Yes, sir.
Would you recommend that instead of cross multiplying?
Yes. So just like multiplication, we have to deal with proper or improper fractions. We can't deal with mixed numbers. So what do I have to do first before I even start?
Common numbers.
Same change.
Same change flip, or the other world? So many phrases to remember. All right, remember that you don't need a common denominator with multiplication and division. That's the nice thing. You don't have to worry about that. So 9 times 7 is 63. Plus 3, 66 over 7. Divided by, we'll get to the same change flip in a second. And then 15 over 28. You could have done the same change flip in that same step, just going one step at a time. So now I've got it set up where I can do the division, which means I need to do the same change flip. So 66 over 7 times flip 28.
28 over 15.
Correct. All right, so let's see if I can do any reducing. What about that 7 and 28? 7 goes in there one time. 7 goes into 28, 4. Anything common between 66 and 15? 3. Yeah, there's a 3 that actually goes into both of them. So 3 goes into 15 how many times? 5. And 3 goes into 66. 22. Yep. So we've taken care of the reducing. So that means at the end we don't have to worry about reducing. 22 times 4 on top is 88. 1 times 5 is 5. Change that into a mixed number. 5 goes into 88. 17 times? Someone check me on that.
That's right.
17.
Okay, with a remainder of 3. It's nice, it's reduced. We didn't have to worry about that because we took care of that before we multiplied. Any questions on that one? So we need to change our numbers up a little bit here in order to be able to do the division or the multiplication. So what do I have to do to this one? Another row. 3 times 9. 27 plus the 8. 35.
35. 9.
Nice. Divided by 4. I really need is 4 over 1, correct. Now I can do the same change flip. So that really becomes 35 over 9 times.
1 over 4.
Can I do any reducing on this one?
No.
And what I
Yeah, there's nothing common besides 1, with 1 and 9, so we leave that alone. There's nothing common between 35 and 4. That just means you can't do any reducing. 35 times 1 is? 9 times 4 is 36. We already know it's reduced. Is it proper?
Yes.
Yes, the number on top is smaller. So we don't even need to change that into a mixed number.
You guys still having class?
Yes, ma'am.
Sorry.
All right. Any questions on that one? this last one with the division, we have two mixed numbers. So we have to convert them into common fractions. So around the world, what will this one end up becoming?
38.
Over 5. And divided by 4 times 20 is 80.
89.
89. Keep the same denominator. Do our same change flip, so keep the first one the same. Times 20 over 89. Anything common between 5 and 20? Anything common between 38 and 19?
89.
38 and 89. I can't think of anything. Anybody else have any ideas? So 38 times 4 ends up being 152. Someone please check me on that one. And then 1 times 89 is 89. 89 can only go into 152 one time, with a remainder of 63 over 89. And we know our answer is reduced because we're reducing it before we multiply. One last topic before the other class marches in. And we're going to talk about exponents. And show you that exponents actually become a really piece of cake as well. We got 2/3 squared. So when you square something, when you take something to the second power, do you agree it just really means 2/3 times 2/3?
Mhm.
Just write it twice. Well, we might do multiplication. Just multiply across. Can we reduce anything? Nothing common here, nothing common there. So 2 times 2 is
4.
4.
9.
3 times 3 is 9. And we're done. 7/5 squared. That just means 7/5 times 7/5. Can I do any reducing there?
No.
So 7 times 7 is
49.
49.
25.
5 times 5 is 25. Converting that into a mixed number, 25 goes into 49
1.
with a remainder of 4, correct?
4. Over 25.
Over 25. This process holds true no matter what the exponent is. If I have 1/3 to the third power, that just means I'm writing it 3 times and multiplying it. Is there a reducing I can do there?
No.
Right? There's nothing common on any of the diagonals. So what's this 1 times 1 times 1?
1.
And 3 times 3 times 3?
9.
3 times 3 is 9. 9 times 3 is 26. Correct. Usually when you're taking the exponent, notice we didn't do any reducing. Right? Because you're just multiplying the same number times itself. So that means your answers are going to be reduced. So that's fun. Thank you very much. There's an evaluation form. I'll pick it up next to it. If you have a chance to fill that out real quick, I really appreciate that. I'll give you some feedback on the workshop. And as soon as you get those done, just put those face down.